Okay, so we will be investigating this data set for logistic regression. We've got an ID at one side, we've got the dependent variable, which is bivariant. We've also got three independent variables. Initially, we would like to test the assumptions, the three assumptions that we'll be testing, and we'll do those all individually. The first one, we'll be looking at whether there is any collinearity between the three independent variables. So the way to do that, first of all, is we will go into descriptive statistics, we'll go into explore, and we will be looking at these dependent variables, and we will be describing them. We want the plots to be correct, we want the histogram, and we want the normality plots. Okay, and dropping down, we can see that our three independent variables are in fact normally distributed. Having established that they are normally distributed, we can then go to our correlation, and we can go to bivariant correlation, and we're looking at all three to see whether there's a correlation between them. And we get out our correlation table, and we can see in our correlation table that the three variables are in fact not correlated. We've used Pearson correlation rather than Spearman because we had established that they are in fact normally distributed. Okay, so we've established that the first of our assumptions has been tested and has been found not to be correlated, which is excellent. So we'll then look at the second and probably the most complex one, which is to see whether there is a linear relationship between the continuous independent variables and the logit transformation of the dependent variable. The simplest way of approaching this one is to have a look at the variables and look at the interaction between the log transformation of the variable and its and the logit transformation of the y variable. So to do that, we need to create a log variable for each of them. So we go into data and transformation, transform and compute variable, and we'll create a log x3, which will be a log transformation of the x3 variable. And having created all three of them, we are then able to check for this interaction against the predicted outcome. So we're going to analyze, and we go into the regression and drop down to the binary logistic regression, and we will reset. We want the dependent variable are y, the independent variables are as they will be, and then we want the interaction between the variable x1 and its log transformation. And to get that interaction, we need this button, and with the two of them selected, we then press that button and then move it across, which will give us that interaction. So we select the x2, pressing the control button down, we then select log x2, and then we put that interaction across, and similarly with x3. And then we can look at, we don't need to save anything at this moment, which is fine. We look at our options. Again, we don't need to do anything at the moment because this is simply testing our assumption, and so we will then produce the variables in the equation is the one we want, and it's the interaction between them and the significance thereof which is relevant, and they are not significant, which is great. So we can go straight on and to produce our final model, which will actually test for our binary logistic model. We'll do our reset. We want y as our dependent variable, and with this time we only actually want the dependent variables in on their own without the interaction. We're testing the actual model itself now, not the assumption. And to do that, we will want the predicted values. We want the probabilities for the predicted values, as we will use them for the ROC curve. And we want the case-wise listing. We've set it at 2 standard deviations, which is very tight, but there's none anyway. So we will continue that. Case-wise, no cases, which is fine. But when we go back into our results, we have the predicted probabilities, which is great, which is what we will then use. And finally, we will do analysis, and we'll drop down to classify, and then drop down to the ROC curve itself. Our test variable is going to be our predicted probabilities. Our state variable, so that's the truth, that's telling us what state the actual case is in the y variable, and the value of the state in this case is 1 for the true state. We have the ROC curve with diagnostics and the coordinate points, and that gives us the area under the curve, which tells us how good at discrimination the model is, and then we can find the value of the point in this table, which is the coordinates of the curve. And the cutoff value is set at 50% because we got 1, and this is our transition point, so 1 for our sensitivity and 1 for our specificity. Remember, this is actually the 1 minus 1. So we have all the data that we require, therefore, to actually report our logistic regression.